I'm making my little cheat sheet to the right over here, and I'm doing the work on the worksheet. So what do I do with these exponents? I subtract them. So this is, let's do this. So this is going to be 3 times x to the 1/2 minus 1/4. Now, I think you can do 1/2 minus 1/4 in your head. If you have half a cup and you subtract 1/4 of a cup, how many cups do you have left?
Wait. You have half a cup.
So if you have 1/2 minus 1/4, if you have half a dollar and you subtract 1/4 of a dollar,
25.
you're gonna have a 1/4 of a dollar left, right?
Yes.
So this is like 2/4 minus 1/4, which
Oh.
is 1/4.
Oh my God.
Right?
Obviously. Oh my God. How did I not know that?
Try to always relate
What
it to
the
something in
heck?
the real world. Okay.
Oh my God.
All right, next one, number 14. This is
Oh,
gonna
he's tripping
require
up. I don't know how to do
a
this.
definition. So an nth power means a to the 1 over n power exponent. That's what an nth power means.
Yeah,
so if I rewrote, if I rewrite this, what I would rewrite this as is x to the 4th raised to the 1/6 all over y to the 1/3. And what can I do with that exponent now?
You can subtract them.
Well, what do I do with these two right here? No, I can't subtract them, Sarah.
Oh, those you multiply.
Yeah, I multiply these.
The 4 and the 1/6.
Good. So I get 4/6, which is 2/3, right?
Yeah.
So x to the 2/3 all over y to the 1/3. Now you wanted to subtract these, but you can't because look at how the bases. See how the bases are different? You can only do that when the bases are the same, and they are not here. So you're actually done. Yeah, you're done. Now you could rewrite it if you wanted to. You could rewrite it. Well, there's a couple ways you can rewrite it. See how they both have a 3 in the denominator?
Yeah.
You could rewrite it as x squared to the 1/3 and y to the 1/3. And then you could rewrite that as x squared over y to the 1/3.
And then the 1/3. Okay.
Out top, if you want, but you don't have to. I don't know how they want that answer written. And you can even write it as a radical again. You can even write it like this: the 3rd root of x squared over y.
Oh yeah, that would work too.
Any one of those might be the right answer.
Okay. I see.
Hard to say. Hard to say. So what would I do with this one right here? I'm not going to do it. I'm just asking, what would I do with that 15?
You distribute it.
Right, and which means you do what with these exponents?
You'd multiply them.
Very good. And don't forget, 15 is 3 times 5. So think of 15 as 3 times 5, because then it's just going to, I'll just go ahead and do this one. So you're going to have x to the negative 4/3 to the 3 times 5 power. And then you're going to have y to the 3/5 to the 3 times 5 power. And now I can cancel the 3's and I can cancel the 5's.
I see.
So that's just equal to negative 4 times 5 is negative 20. X to the negative 20. And y to the, what, 3 times 3?
Yeah.
Y to the 9th. And now that negative 20 goes to the bottom.
Goes to the bottom, put the y on the top.
So this just equals y to the 9th over x to the 20th.
Okay.
Okay.
Cool.
Sorry,
yeah.
I kind of ran out of room there.
No, that's
let's do 16. Let's distribute. So this is 125 to the 1/3 times x to the 18th I'm just going to go ahead and do the shortcut. Times 1/3, right? You know you're going to multiply those, right?
Yeah.
All over 8 to the 1/3 times y to the 12th times 1/3. Okay, what's going to happen with these when you multiply them?
You're going to get 6.
And what's going to happen with these when you multiply them?
That's going to be 4.
Good. And 125, do you recognize that that's 5 times 5 times 5?
Oh, yeah, it is.
Is it? It sure is. So this is 5.
Okay.
It's a 5 cubed is 125.
Yeah. 5.
So that's 5x to the
X.
6th, like you said. And what's 8 the perfect cube of?
2.
Very good. So that's 2
I guessed
times
on that
y.
one. Let's go.
Good guess. So these are things you should memorize. Perfect cubes, perfect squares.
I have them
perfect
written
cubes.
down. I just don't. I don't
Perfect
remember
squares
them.
are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and you can do more. But you should have at least those. Perfect cubes are 1, 8. Just multiply each one of these by the number again, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? I'm making a little cheat sheet for you here.
Yeah.
That's squared. So this is x. This is x squared. And this is x cubed. So this is 27. This is 64. This is 125. What's 6 times 36? 6 times 30 is 180. 6 times 6 is 36. 180 plus 36 is 216. That's
my teacher
216.
said we don't have to know above 6.
Yeah, but it's not bad to have an idea. 343.
Okay. I see.
Those are just good ones to have memorized.
Yeah, definitely.
I'm going to leave those other ones to you to finish.
Yeah.
Because I know you've got some more. Solve the following radical equations. Well, the first thing I would say is, don't tell me what to do.
Don't tell me what to do.
I was waiting for you. The next thing I would do is I would just go ahead and do it. Not because you're telling me, but because I want to.
Exactly.
So how do I get rid of a third root? Cube both sides.
Yup.
So 2x plus 1 equals 27. Solve that equation now. 2x equals 26. X equals 13. Let's check for extraneous solutions. That means plug it back in and make sure it actually works, because sometimes it doesn't when you do this.
Yes.
And so, because when you cube both things, you might have just introduced a negative that, like, you might have introduced an extraneous solution, a solution that didn't actually work in the original equation. So we'll see when one of those pops up. So 13 times 2 is 26 plus 1 is 27. 27 cubed is 3, or the cube root of 27 is 3. That's perfect. So that works. So you can circle it. Next step, next problem. First step, you got to move the 2 over. Got it? What's the next step?
Cube both sides? Not cube. Square both sides?
Square both sides. Good. Got it? What's the next step?
Solve it. Subtract 3. 4x
next step.
X equals that. Yes.
3 halves. Now plug 3 halves in and see if it works. When I plug
I don't
in
know
3
how
halves,
to do that with a fraction.
Sure. Look, watch how easy this is.
Fractions freak me out, man.
Watch. I'm going to teach you how you don't have to be afraid of them. When I plug 3 halves in, what happens to the 4 and the 2?
They cancel out.
And you get a 2 left over.
Yeah.
What's 2 times 3?
6.
6 plus 3.
9.
Square root of 9.
3.
3 plus 2.
5.
Check.
Oh my god. What the heck?
Okay.
That's kind of trippy.
Okay.
Okay.
So that is not an extraneous solution. It works out.
Yeah.
So that's called a check. Let's do the next one.
Thought
What's
bubble.
What's the first step? There you
go. Move the 8.
Good. 15. Now what?
Oh, divide by 3.
Now what?
Square.
Check it.
Check it.
What's the square root of 25?
5.
What's 5 times 3?
15.
What's 15 minus 8?
7.
Bada bing.
Let's go. Okay. Okay.
Next one. 2x minus 4 to the 1/3 equals -2. I'm moving the -2 over. Now what?
Yeah. I don't know.
Well, how do I get rid of a cube root?
Cube it? I don't know.
Yeah, that's right. You cube it.
Oh, really? What?
Yeah. That's how you get rid of a cube root, because when you cube it, what's 3 times 1/3? It's 1, which means it's gone. 2x minus 4 equals -8.
Okay.
By the way, I made it look like I'm only cubing the 2. I'm actually cubing the -2. So let me fix that a little bit here, because I don't want you to go back and look at it and say, but why didn't you cube the negative? I was cubing the negative. So -8, now what?
Subtract the 4, or add the 4.
Add 4, 2x equals -4. Now what?
X equals -2.
Good job. And now when I plug that in, let's check it. What's -2 times 2?
-4.
Good. What's -4 minus 4?
-8.
Good. What's the cube root of -8?
2.
-2.
-2.
Right? And what's -2 plus 2?
Equals 0.
Perfect. So that worked out.
Let's go.
All right. I'm going to leave the next one for you to do.
Yeah.
No, I'm not. No, I'm not. Because there's going to be an extraneous solution. And you want to know
really?
how I know?
What the heck?
Yep.
How do you know?
I know because watch this. When oh no, maybe there won't be an extraneous solution. But this is definitely a different kind of problem because there's an x on the other side. I subtract 1, right? The first step is to isolate the radical.
Yeah.
Now I square both sides, because I have to get rid of that square root, right?
Mm-hmm.
So when I square both sides, on the left I get x plus 1, and on the right I get, please don't say you don't understand this. Please just be like, oh, I get it. Yeah, I totally get that.
Oh, no, I actually do get it. I actually do.
Good. Because you can't distribute this negative, you can't distribute this 2 into here. You just can't do it. It doesn't work.
You have to factor it. You have to factor
not factor
it.
You have to unfactor it. You have to distribute it.
Oh,
yeah,
do that.
Foil it.
You're
foiling it. First inside, outside, last. So you're going to get that.
Oh,
just trust
so
me.
annoying.
I know when people don't get that. It's so annoying. Now I have, what kind of equation do I have?
A regular one.
Quadratic. Good job. This is a quadratic. So I have to subtract. So I have to put them all on the same side. So I'm going to subtract x and subtract 1. So x squared minus 3x plus 0. Get what I did there?
Yeah.
Why do I have to do that? Well, because now I can factor it. And that's how I solve a quadratic equation. So what are my two solutions? Either x equals 0 or
0.
x minus 3 equals 0. Which means x equals 3. So either x equals 3 or x equals 0.
Okay.
But I have a feeling one of those is going to be extraneous.
Yes, that's usually how it ends up working out, I think.
Yeah, a lot of times that happens. So when I plug this in, what do I get? 0 plus 1 is what?
1.
Good. And what's the square root of 1?
1.
And what's 1 plus 1?
2.
And what is x again?
Not 2.
Not 2, it's 0.
Yeah.
So this is extraneous.
Okay, okay.
Let's try 3. What's 3 plus 1?
4.
And what's the square root of 4?
2.
And what's 2 plus 1?
3.
And what's x again?
X is 3.
3. So that worked.
Okay, okay.
Aye.
Yes.
Next, square both sides. I'm going fast now for the sake of time. Okay?
Yes, that's fine.
You got 5 minutes. Squaring both sides, I got 7x minus 1 equals 5x plus 5. Awesome. Probably have an extraneous solution though, or I might have an extraneous solution. We'll see. Subtract 5x from both sides, you get 2x. Add 1 to both sides, you get 6. Divide by 2, you get x equals 3. Let's check it. When I plug in 3 here,
does it matter what side you plug it into?
You got to plug it into both of them, all of them.
Ah, okay, okay.
What's 7 times 3?
21.
And what's 21 minus 1?
20.
20. So the left side is square root of
20.
20. What's the right side?
15 plus 5, 20. 20, square root of 20 equals square root of 20.
And that works out. All right, let's try the next one. See how this is like number 35? I'm going to subtract the 2. For the sake of space, I'm going to do it like that. I'm going to square both sides. So 2x minus 4 equals, I'm squaring x minus 2. So that's x squared minus 4x plus 4. Trust me.
Yeah.
Do it on the side if you don't see that. Now I'm going to move it, set m equal to 0. So move everything to the right. So x squared minus 6x plus 8. Ooh, I hope that factors.
Yes.
So 0 equals, I bet it is going to factor. 0 equals x minus 2 and x minus 4.
Yes.
Which means x equals 2 and x equals 4. But let's check them.
Yes.
If I plug in 2 here, right? You got to plug in 2 for all my x's. Look only at the black. Don't look at this. Look only at the black. When I plug in 2 here, I get 4 minus 4, which is 0. So square root of 0 is still 0, plus 2. 2 equal, which equals 2. Does 2 equal 2?
Yes.
It does. So that is an answer. X equals 2 is an answer. Now don't cross out x equals 4. That could be an answer too. Let's just find out. Okay. So now let's try 4. What's 4 times 2?
4 times 2 is 8.
Good. And what's 8 minus 4?
4.
And what's the square root of 4?
16.
Square root of 4 is 2.
Oh, 2, yeah.
Not square root. Remember, the half power is 2 plus 2 is
4.
4. And that's what our right side is.
Both of them work.
Work. How about that? Like I said, don't cross them out. Don't assume they're not going to work.
Yeah.
All right.
That's totally fine if both of them work.
Totally fine. Totally fine.
Okay.
By the way, I'm going to have to add another slide. Whoops. I'm going to have to duplicate that slide. because this next one is not going to happen on that little space that we have there.
Okay.
So let's erase all this stuff real quick. And let's move it up and let's try this last one, okay?
Yes.
For the sake of time. Are you getting this stuff?
Oops. Yeah.
Good. You'll just have to keep practicing more on your own as well. Okay.
Yeah, definitely.
So we'll do this one now.
Where is? Okay.
So the trick to this one here is you want to move one of them over to the other side. 7x minus 6 equals 5x plus 2. Move it over to the other side. Now, if I square both sides, I just get 7x minus 6 equals 5x plus 2. But there's a really good chance I'm going to have an extraneous solution here. Now let's move the x's to the left. So that's 2x. Let's move the other things to the right. So that's 8. So x equals 4. Oh, I could fit it into there. Now let's check it. What's 7 times 4?
28.
What's 28 minus 6?
22.
Good. So the square root of 22 minus, what's 5 times 4?
20.
And plus 2?
22.
And that equals 0. That works out.
Huh.
Last one, number 39. Move the 6 over. Square both sides.
Yep.
Subtract x from both sides. Factor. Let's pray it factors. 12. How about 9 and 4? -9 and -4.
Yes.
So x equals 9 and x equals 4. Let's check if they're extraneous. What's the square root of 9?
Square root of 9 is 3.
3 plus 6 is?
9.
Works.
Okay.
What's the square root of 4?
2.
2 plus 6. Is it
8.
4? 8. It didn't work.
God dang.
Extraneous. You know why that's extraneous?
Because it doesn't make it work?
Right. But why did that happen? Where the heck did that come from? Well, what's the square root of 4? 2. But what if it was -2? Then it would have worked. -2 plus 6 would have been 4. That's why you get those sometimes. Because look what you did here. When you took the square root, when you squared both sides of this, you just made the answers 2 and -2 the same thing, essentially. Because 2 squared and -2 squared are both +4. So when you square this, you just introduce the potential for an extraneous solution because of that.
I see.
That's why. That's what's happening here. All right. Okay. I think we're good. Yes? Are we good?
Yeah, that's good enough.
I think you can get these. Yeah. This is what we talked about before, right? One thing I'll say about these, make sure you do the 1/2 power first. So think of this as -64. You can't really take the 1/2 power of -64 because it's right. You can't to the 1/2 power and then think of it as cubed. You can't take the 1/2 power of that negative. Whereas this one, see how that negative is not part, see how that's not in parentheses?
Yeah.
That's like saying -1 times 64 to the 1/2 power.
Yeah.
So that's just -8.
Yeah.
See this right here? That whole thing is in the parentheses, so that whole thing is being raised to that power. So -1/25, but take it to the 1/3 power first and then square it. What's the 1/3 power of 125? -125?
5.
-5.
Yeah.
And what's -5 squared?
25.
Positive 20. Positive 25. Very good.
Okay.
Okay. So for this one, first, for number, whoa, what happened there? For number 27, first think of it as the 1/2 power, and then multiply that to the -5th power. You don't need a calculator to do that. Because what's the 1/2 power of 4?
2.
2. And what does it mean to be raised to the -5th power? It means 1 over 2 to the +5th power. And 2 to the 5th is 32. By the way, you should also memorize the powers of 2. So the powers of 2 are 1, 2, 4, 8, 16, 32, 64, 128, 256. You should have at least those memorized. The powers of 3 are 1, 3, 9, 27, 81 times 3 is 243. Got it? You should have at least those memorized.
Yeah.
So those are just, these are powers of 2. These are powers of 3. Okay?
Yeah.